טוב, שמי הלן בראבו, אני מפרודקט מנג'מנט של צ'קמרקס. אני הולכת לדבר היום על Node.js והחולשות הארכיטקטוניות המובנות בתוך Node.js, בהיבטי כתיבה כמובן, שכל אחד שמשתמש ב-Node.js צריך לקחת בחשבון. קצת... מה זה? English. Okay. The lecture was declared in English, and I'm actually used to lecture in English. I'm not a native speaker. It's just the usual way we lecture in outside of Israel. It would be nice to speak Hebrew, but since we have agreed on English, let's continue in English. I hope it's okay from your side. So I'm from Checkmarks. Checkmarks is the vendor with the cool t-shirts outside there. And we are also as cool as our t-shirts, right guys? Woo! And we deal a lot with code, we deal a lot with code security, and we know a lot of things, not just because we experience it, but because we see it at our customers. We see what problems are common. And one of the most interesting things is Node.js. So I'm going to talk about DOS, denial of service, which Node.js architecture makes possible, and the weak crypto, and the JSON usage in MongoDB, and RedOS, which is also connected to MongoDB. So what Node.js is? Node.js is server-side JavaScript, which is taking the world by storm. Really, if you ask any of your, maybe yourself, but any of my personal friends who consider to open a new project and start a new project, new product, they first of all look at Node.js. And why is that? Because Node.js was invented for developers. It was invented in 2009. And the first project presented by the inventor actually used the event-driven and non-IO blocking mode. And it was amazing. He got standing uploads at this conference. And I really would like to get standing uploads one day. It's something that really shows a huge difference that this project made. But, however, it's not exactly however, it's just an addition. First of all, the data-intensive real-time applications are getting the most out of Node.js. But not just that, it's also some sort of a minus of this platform. So Node.js is getting the world by storm. IBM, Amazon, Microsoft, all those guys are using for a long time in Node.js, and everyone by today is already there. So what we have here, we have the pluses of IO intensiveness and DB queries, which are made easy, and application with high usage and high user interface. But on the other hand, the CPU intensive applications and heavy lifting calculative applications are a bit problematic. And that's one thing that I'm going to show you now. So this is a great example of the next single thread architecture of Node.js. Let's go back. You see, there is a guy which is taking orders. And there is a girl who is handling the Coke. And behind the counter on the other side, there is a guy who is handling the burgers. And there is also someone handling the chips. So you're coming and you're asking for double Coke, double chips, double everything with cream on top. Right? It's McDonald's. So the guy over there takes your order and sends chips to the chips guy, and Coke order to the Coke girl, and the burger order to the burger guy. So he dispatched the tasks. Now, the problem happens when he now needs to calculate the whole order, and he is the only one who knows the calculation. he can't dispatch it to someone else. And that's exactly what happens to Node.js. We have an event queue, and all the events are standing in the same queue and go into event loop. Now, the event loop handles the event and dispatches it to either file system, database, or network. But as long as calculation has to be done, it has to be done by the event loop itself, and it can't be dispatched. Until this calculation is not over, the next task is not getting in, the next task is not getting handled. So there is a structural preparation for which security problem? Right, DOS, denial of service. So very simple function which is running and doing summary of a number that I'm going to show you to demonstrate this problem. So I have a small application which is running the code you have just seen and summarizing the number 10 that you can see here, and it's 55, runs pretty fast. So if right now I will run this again, which is a bit bigger number, and then run this, both of them, you will not see I can change it. It's not a good example because I should better change it now to like 9. Right? So now the heavy calculation is running, and it's also blocking the calculation for the easy one. Once the heavy calculation is completed, the easy one is completed right away. So this is a very small example of how heavy lifting can block the event loop, because it can only handle one at a time. That's an architectural, structural problem that we have to be aware of when we do the design, the architectural design of our systems. That's one problem. Now, I would like to show you a different thing which has something to do with crypto. And for that, we have prepared and built a small website that does something very basic. It takes a name and an email and provides you with a random password. It's sometimes quite a lot used for registration in different applications. So it's a very secured site. You see, there is a lock over there. You're good. It's amazing how locks makes us relaxed, and it's very secured as long as the picture of the lock is there. So this is, no, I will not start with the demo right now. I will go a bit with the flow. So what's behind the application? We take a basic function which creates a new user, and then pseudo-random number generator runs and generates a number, and then we hash it with MD5. That's what we do with this application. So what the target of this demonstration, what I am claiming to be able to do, I will create 3 users just for fun, and once having a PRNG crack, an MD5 crack, I will be able to predict a force password as well as all passwords after that. This way being able to hack any user of this application. So just to make this demo, we have to create 3 users and get 3 fake passwords, right? So let's do that. Okay, I have called the user OWASP. And this is the first one. Let's take it hash number and keep it here. Let's take another, create another one. And keep it 2. Create this third one. And a fourth one. The one that we would like to predict with our hacking tools. Okay. So that's the fourth one. Now let's go back to the presentation, and our next step would be to open the MD5. Because the random number generator, pseudo-random number generator, it creates floating numbers. It doesn't create hash numbers, and we have the hash numbers, so we have to crack them back into the floats. Now, once in order to open the MD5, it's pretty easy job, done a lot in order to crack passwords. And for that, we have created a rainbow table. It's a pretty heavy rainbow table, so we have put it on the cloud. It's not local. And in order to crack the MD5s, it will take me a bit of a time. But I do have an application that does exactly that. Okay, I will be taking each and every one of the MD5s I have got, and I will brute force it to have the real number. Now, about the PRNG. PRNG is pseudo-random number generator, and it's known to be weak. It's known to be weak. There are articles about that, one very much known by our colleague Amit Klein. Let me know when it will finish and will go. It's very, very slow. And one of the problems of PRNG is that it's the structure of how it works. And let me show you. Okay, that's basically how the formula of PRNG works. We are, once the software is coming up, it brings the seed, and from the seed, the formula creates state numbers. And from each and every state numbers, second formula creates the random number. So what we are going to get in our passwords is basically MD5 random numbers. So what we need to get in order to know the fourth random, we need to get the 3 or the third number, we need to know 3 in the row, and we also need to get their state. And that's exactly what our brute force is doing. Let's see if it's going forward. Okay. I think we have a connection problem here, that's why. Or maybe I have a space here. Let's try another. If it will not work, it will be, of course, very sad, and you will not buy my words for it. But basically it works, and hopefully it will... Oh, now it did work, because the problem was the space. So let's take the number and brute force the second one. hopefully no spaces here. Okay, still takes time, but hopefully works. I really don't like demos with slow performance because then you have to wait and I have to wait, and we have another one. Let's take it. Take the third one, and that's the last one we need to crack. So now we can go get some smoking, something entertaining like that. I have been told that to make people feel very nice with you, you should tell something like, my grandmother is usually telling me this or that. But my personal grandmother doesn't even like Node.js. She prefers Python. So we are getting close, and that's our third one. Okay. So now let's take it one step further and just brute force the three numbers. Okay, so now we basically, what we do, we combine the three numbers into this formula, and we are trying to get the fourth number. And what we have done behind the scenes, we have right away randomized the number to make it clearer and faster. Da-da-da-da. Let's hope it works. So we have the hash. Let's see if it's the same. Yeah. It's a very heavy copy-pasting here, so sometimes if you are wrong in one copy-paste, the demo doesn't work. But this time it works, so I'm very happy about it. And that's basically the demonstration of the weakness of PRNG. Why the weakness of PRNG is not a problem in regular JavaScript? Because for JavaScript, it's not the same instance each time. For each and every appearance, for each and every user, you have a different instance. For Node.js, they are all coming from the same V8, which is running on the server. And that's the main problem of this weakness. You have just to be aware while using this function of Node.js. So next one. Yeah, that's what I have just said. Let's go to JSON. JSON and MongoDB. JSON and MongoDB are two very basic ideas of usage in Node.js. MongoDB is a NoSQL database which is using documents rather than tables. And while using documents, it also stores JSON documents in dynamic format. So look at this example. This is an example of how the MongoDB works. You can have a document which says card, which is an item, and its quantity. Another document can be of a totally different type, which is name elephant and its size. And once you have this database, you have to run a find function, and you can run it in various formats. So you can find every document that has a quantity of 15. Or the next example is actually a JSON expression. Find each document which is, has a quantity greater than 25. And that basically is the weakness that we are going to see now. Once you can use an expression greater than, and Node.js takes it automatically and converts it and runs it, it allows basically to manipulate the same way as regular SQLi is manipulated, or very similar to it. Because now instead of using a string of username and a string of password, we are using a JSON expression. And that's a MongoDB injection. So just to show you how it works, I also have a small demo which works faster than the previous one. So you can see here, if we try user which doesn't exist, and if we try an admin user which does exist. So it didn't let us in before, and it does let us in now. So let's try and use what we have just seen in our demonstration. Try to see to send a post rather than a get, and you will see the GT greater than A and password greater than A. And welcome, it gets us in. It gets us in as some random user, the first user that he found in the MongoDB, which is has a username greater than A. That works as simple as that. So what would be a solution for this problem? If a sanitation routine, what could be a sanitation routine which will fit this situation? The sanitation routine acceptable in such a case is comparison. When you take a password candidate that you just got as an input from the user, and then you take the password that you already have in the database and compare them. This is a perfectly acceptable solution. However, in Node.js there is a problem. If you remember, Node.js is a single thread and it's very sensitive to heavy calculation. So one of the ways to create a denial of service by regular expression for Node.js is by giving as a password very long regular expression. Let's see how it runs. As a demo for the same example that we have just used previously. Here. Now it will take inches to calculate this password and eventually bring it in. Another thing which is very important for Node.js, that it takes about this small calculation, it's performed on my localhost, it takes about 25% of the CPU. So if you have a server which has to handle multi-users, it's even heavier and more problematic concept. So what is the way out of it? It's pretty simple. You can do the comparison sanitation, but it's very important, as always, to validate the input length and its structure and the permitted characters. I'm sorry I am not bringing anything new here, but unfortunately, from our experience, as I told you, we see a lot of code. It's amazing how often we do see those problems within the code of our customers. It happens in almost each and everyone, because people just, and developers especially, are not aware of the sanitation routines, more and more, of course, as the time goes, but still not enough. So that would be it. Thank you very much. אפשר שאלות? אפשר ארוחת צהריים. רעבים, תודה.